Woohoo!
All right, so we are going to get started with the fifth session of the day. I am pleased to introduce Matt Moen. I am definitely looking forward to this. I've heard bits and pieces about Clevis in the past, but I hope y'all are as excited as I am to see this. So yeah, take it away.
Thank you very much. So, yes, my name is Matt Moen. I live here in the Austin area. Who here is from out of town? All right, quite a few. All right. Who here is from out of state? Okay, where? Yeah. Columbia, okay. Tennessee, all right, fantastic. Well, welcome. So I'm here to talk about, I live here in the Austin area, as you can see on the screen here. I'm here to talk today about Tang and Clevis. Tang and Clevis are awesome. Who here has heard of Tang and Clevis before? Okay, so like 5, 6 people, something like that. All right, so you actually, on our title screen here, we actually, we can see, this is stolen here from Wikimedia Commons, what we've got there in the middle, that little image. What we've got here on the outside, this thing is called a Clevis, and the thing in the middle is called a Tang, and then this thing here is called a pin. And what we'll be talking about today will involve all of these things, except they'll involve Linux and will be totally awesome. So yeah, I'm in the Austin area, and I've got letters after my name, which means I passed some dumb tests. This is a Linux con. I am a Linux nerd at heart. I remember once upon a time, many, many years ago, I ran in the Tampa Bay area something that was called the Debian, what did we call it? The Debian Social Lug. It was basically an excuse to hang out at pubs and talk until early hours in the morning about ridiculous nonsense. It was lots of fun. These days, I kind of play in the security space. So, hey, again, we've got a bunch of folks here in Austin, right? Yep. I think I saw a bunch of names here. So there are a bunch of nifty security groups. If you're interested in this thing, sort of closely associated with Linux. Some of these things are way more Linuxy than others. Starting there on the left is Austin ISSA. I'm currently privileged to serve as the president of Austin ISSA, and we have a meeting coming up next Wednesday, October 8th, and you should totally come. You can check out our website at austinissa.org. We're a local nonprofit organization. We meet at an Alamo Draft House, so it's like a mini half-day con. It's going to be awesome. We've got a speaker who's going to be talking about ML, and you're like, oh no, this dude's been doing this stuff for years. He's a hardcore Linux nerd, and he's going to be talking about the domains in which ML is actually useful in the security space and all the areas where it's total BS. It's going to be awesome. Also, we've got DEF CON 512. This is the local DEF CON meetup. It kind of feels like what an old lug used to be, at least at a handful of the tables there. It's very cool. OWASP Austin, if you're interested more in the application security space, that's something you might want to check out. And also AHA, that's the Austin Hackers Association or the Austin Hackers Anonymous. Watch out, those guys are wild, but they are fun. So, somebody hacked me, huh? Or something. Something was a little loose there. Hold on, let's see. Oh, wait a second. No, it's not that. Yeah, that's not what we want. We definitely don't want that nonsense. Yeah, there we go. Sorry, folks, experiencing technical differences. Other local conferences in the area. So just a handful of other things. LastCon is coming up at the end of this month. That's the Lone Star Application Security Conference. It's not cheap at this late hour, but it is awesome. And that's actually run by the local OWASP chapter. It's very cool. Is Kyle in here? No? Okay. Anyway, he's around at the conference. He runs that thing. It's a very awesome conference. Initech is almost a volunteer-run conference. Our chapter runs the security chapter of it. B-Sides Austin is very much a security-run conference, and that's coming up in 2026 on the website. It says, if you're not familiar with B-Sides, they're kind of awesome security conferences. Again, this is security-related. It's Linux adjacent. It's cool. Okay, on to Linuxy stuff. Story time. So let's say you work for a company that is in the retail space. So let's say this company is in the business of selling sandwiches. So it's a growing sandwich chain. Let's say this sandwich chain is called Timmy Tom's. And so you've got this sandwich chain, and you're working for it, and this sandwich chain is awesome. It's awesome in that you've got really, really, really cool infrastructure. So what you've got going on here is in the back of all of your Timmy Tom's stores, you are running a Kubernetes cluster. You are that frigging cool. And before you think this sounds totally preposterous, there are actually lots of retail stores that are doing this. They're like running on crappy commodity hardware. They're running a Kubernetes cluster on like 3 crappy desktops. Yeah, this is a thing. So anyway, you're doing this, and in the back of all of these Timmy Tom's sandwich shops, and all of a sudden your CEO, reads some crap in the Wall Street Journal, and is freaking out because he's wondering, how secure these things are, and particularly what's going to happen, like when somebody breaks into your Timmy Tom's and then runs off with the stuff, like. Your developers, by the way, who in here is a SRE? You have any SREs? Okay, cool. Who's a developer? Okay, do we have any sort of developer? Do we have any Linux admin types? Some? All right, cool. So your CEO is freaking out because your developers are being pretty good about not having personally identifiable information being stored locally on these Kubernetes clusters in an unencrypted fashion. But, it's always easy to screw that kind of thing up. And this was kind of a rush project. You kind of shoved them out there. And, anyway, the CEO finds out that in the process to rush everything out there, you're not using on-disk encryption because you're thinking, okay, we've got a manager in these stores who's going to, enter the decryption key password. Ugh. And so anyway, it's an ugly situation, and what are you going to do? So what if I told you that bad people try to do bad stuff and steal things? What would happen in your company or your enterprise or whatever you've got? What would happen if information was stolen from your data center? What would happen if drives and disks were stolen from your data center? What would happen if stuff was stolen? What would happen if somebody walks off with pieces of your cloud infrastructure? That'd be bad. What would happen if your edge computing Kubernetes cluster walks off? So data theft. Data theft is not cheap. Data at rest encryption is not something easy. It will protect you from common thieves, with crowbars. But data at rest protection like this sort of thing will not protect you from other things necessarily. I mean, what will it protect you from? It might protect you from ransomware, maybe. It might protect you from elite hackers, but no, probably not. You're probably screwed, if they have any sort of skills whatsoever. By the way, who here recognizes this? Yeah? Okay, cool. Yeah, if you haven't seen Hackers, go watch it. It's awesome. So Linux root partition encryption. You've got this chicken and egg problem. You if you screw this up, you will denial of service yourself. That's not good. You normally have to manually enter your password at boot. Yuck. Who here is currently on production systems doing root partition encryption? Anyone? Who here is doing it at home? A lot more? Yeah, and you're entering passwords at boot uptime, aren't you? Yeah, exactly. So you could theoretically use an escrow service. That has its own problems, some sort of escrow server. You could do that. You could also use that thing on your hardware called the TPM. Who is familiar with TPM? All right, almost everyone. Cool. So yeah, TPM. It's pretty ugly. So TPM stands for Trusted Platform Module. Do you trust it? I mean, it's kind of hard to hack. I mean, honestly, I mean, the open source nerd in me is like, screw this closed nonsense. But in practice, it's actually not, it's tamper resistant, but not tamper proof. But the resistance is pretty, sophisticated. I mean, especially with the newer ones. It is not easy to mess with, but that doesn't mean that you can't. That doesn't mean that no one can. So, I've actually seen folks that, I know of folks that at home are buying the right sort of lasers online and are not using modern chips, but using older technologies from like a decade ago in their spare bedroom, are futzing with things so that they can consistently flip bits on chips, and specifically flip certain bits if they orient the laser just right, and that's kind of scary. And they're able to do this, with cheap crap they're buying on AliExpress and whatever in their spare bedroom. So what could somebody with real resources actually do? More. Yeah, but lasers can definitely do cool stuff. So, more practical circumvention than the laser flicking thing, because, there's a guy, I'm going to show you a video here in a moment, briefly, but I'll just explain beforehand what this video shows. There's a security researcher guy named Stack Smashing, and he's actually got a proof of concept where he is in real time. I know this is a Linux conference, but don't worry, there's Linux involved with this. It's really cool, and also it shows how Windows sucks. This guy is going to demonstrate how he can lift the decryption key from the Trusted Platform Module on a Windows laptop, and then shuck the drive and decrypt it and access all of the encrypted Windows stuff on a Linux system. So yeah, here we go. Brace yourself. And I'm going to actually show that URL at the end with my thing at the end if you want to see this in depth. This video is worth watching if this is even mildly interesting in you. So here we go. He's going to unscrew this laptop here. And then he's got actually a Pico Pi that he's got some custom crap on, and he's going to drop this Pico Pi onto the TPM with the legs touching the legs of the chip, and he yanked off the decryption key, and that took all of, 30 seconds or whatever it was on the stopwatch there. Yeah, I mean, with that, he's able to shuck the laptop drive out of the system, and then on a Linux system, read everything. I guess it wasn't encrypted. Well, not that well. So, that's not good, right? So what exactly is this module? It's a flipping computer. It's a flipping computer that maybe theoretically was made secure, but whoever wanted another computer that you didn't really control inside your computer, right? I mean, that's what every Linux nerd wants, right? Duh. So what if there was a better way? What if instead of this nonsense, what if we could do network-based decryption? You're thinking to yourself, wait a second, networks aren't secure. Well, hold on there. This is kind of cool stuff. So we're going to get a little nerdy in terms of cryptography here, but we are at the Texas Linux Fest, so I think we're here for nerdy. So there's this cool protocol from dudes from Red Hat. I don't work for Red Hat, and there are probably some Red Hat people here. So thank you for this. This is cool stuff. I don't want to murder their names in case people know them. I don't know if they still work for Red Hat. I haven't looked that recently. But they made this whole key exchange that it's kind of weird. You actually end up throwing away one of the private keys because you don't need to use it after the initial setup part. It's kind of weird. But this thing will provide you decryption without escrow. And it's a variation on Diffie-Hellman. Who here is familiar with Diffie-Hellman? Almost everyone? Good, okay. But for those who aren't, who here is not familiar with Diffie-Hellman? A handful? Okay, that's cool. So here's the short answer with Diffie-Hellman. Again, this is yanked from Wikimedia Commons. But in short, Diffie-Hellman allows you to have two public-private key pairs. So two people across an untrusted network like the internet have two matching key pairs. They're mathematically associated with each other, the private and the public key. They share their public keys with each other. Some math is done, and there's a handshake that goes back and forth. And in short, at the end of this, they both have a shared secret that they never transmitted over the public network. And they were able to mathematically calculate this by only sharing their public keys and keeping their private keys private. And this is how we're able to buy ridiculous nonsense online and all sorts of meme t-shirts and things that talk about Linux and clouds and that sort of thing. So McCallum-Rayla is different than this. It's a slight variation. To step through it, we've got two pieces here with this, and I'm going to actually show a live demo in a bit. It's going to be cool. But we've got two servers for this demo here. Well, we're going to call them servers. They're Raspberry Pis, but they make for good demo machines for this sort of thing. So this would be our Tang server. And this over here is going to represent our, quote, big iron server, or maybe it's our desktop in the back of Tibby Tom's that is being decrypted at boot. But that's the actual workhorse thing, and this is some really lightweight thing. This really doesn't have to be anything special. And so those are our two components. This is a little confusing. It's like X windows, like what's the server, what's the client? Okay, yes. In this case, the server is a little tiny thing, and the client is our, quote, big iron server. Yeah, hang with me here, but that's... So anyway, we've got the Tang server. First, the Clevis thing on our big iron server. Our server's booting up, and it pokes out on the network and tries to talk to our Tang server over here. And the Tang server sends its public key back, and there's this handshake thing. The client on the Clevis side generates a new public-private key pair. Math happens, and the result is stored. And then our client on our big iron server, our client then discards the private key. Ooh, amazing. Then... a little bit more. It generates well, actually, no, this is the step that happens at boot up later on. That was the part where trust is established. Then when the server boots up, the, quote, big iron server generates a new public-private key pair. Another handshake thing is generated, and the original key is reconstructed on our big iron server, and it can decrypt its root file system. And this key actually was never being stored anywhere. Just cryptographic bits that are able to regenerate it are stored on two different machines. We'll go over this in some more depth. This right here is the discrete math that explains how all of this is legit. I've totally stolen this from a presentation from Red Hat. Red Hat, don't sue me. But you can find this presentation at the URL below, and I encourage you to check it out if this sort of discrete math thing really, really geeks you out. Needless to say, math nerds have looked over this in depth, and math nerds have signed off and said, yep, this is like Diffie-Hellman. It's totally secure. It's awesome. Nobody's found any sort of, massive flaw in this kind of thing. It really is just a variation on Diffie-Hellman, what's going on here. So, the Tang server. This would not be our big iron server. This would be the little tiny thing that's running the little tiny component. It can be something really, really lightweight. And by that, I mean it could be running on a Raspberry Pi Zero, and a Raspberry Pi Zero could be, providing this service for like maybe a huge data center. When I say this is lightweight, it's really flipping lightweight. So that's the quote server side in this whole configuration. And it is actually, well, the server, it's not running HTTPS. And you might be saying, well, that doesn't sound secure for something secure. That's okay, because the stuff that's passing over it is insecure. And also remember, the client piece of this, the client piece of this running on the Big Iron server needs to run in init ramfs. And yeah, who wants to have HTTPS and init ramfs? So it's purposely kept, KISS. So yeah, anyway, it handles the Michaelim, Michaelim and Rayla developed this thing. Clevis, that's the piece that's running on the Big Iron server. It negotiates with the Tang server. It uses a LUX slot for metadata. And you can still decrypt manually with a passphrase in one of the other LUX slots. So this does not prevent you from going old school like we are doing at home. It's very awesome. So who here, probably most people are familiar with LUX. This is Texas Linux Fest. Who here is not familiar with LUX? No shame. There's nothing wrong with it. Everyone learns, initially. I didn't know what LUX was at one point. Okay, LUX stands for the Linux Unified Key Setup. In short, it provides one master key for decryption on a partition, and then it has slots. Specifically, it has 8 user slots. So it has 8 different, theoretically, you could have 8 different passphrases to decrypt your partition, your LUX partition. So you could have 8 different passphrases that will all decrypt the master key that will give you access to the partition. It's actually really robust, cool stuff. So the way this would work here normally you would have slot 1 containing your passphrase, so you go install your Linux operating system and you set it up for encryption, and we're keeping it simple here. You're just using one partition for the sake of this conversation. And it will configure things so that the one slot will have the passphrase you put in during installation. Then every time when you boot up, you will have to enter the passphrase for it. It will use slot 1 to decrypt that, getting the master key, decrypting the partition. Everything's peachy. It's great. So with this Clevis thing, same thing. We can still keep the passphrase there if we want. We could delete it and remove it if we want as well. But then slot 2 in this case will be the stuff that's needed for this awesome Tang Clevis magic handshake thing that allows us to automatically decrypt at boot. So this is great. We've got the Tang thing that has to be somewhere or other. We've got the Clevis thing. How can we protect the Tang server? Because obviously, if you've got both of these pieces, clearly you can decrypt the partition. That's not good. So we could put the Tang thing on the other end of a VPN. That might be a reasonable option for our Timmy Tom's chain. The problem with this is then we can't boot up the server if our internet connection is down. but that may be a reasonable option for you. You could theoretically hide it. So, I mean, we showed how it's could run on a Raspberry Pi Zero. The Raspberry Pi Zero could theoretically be thrown up above a drop ceiling or something like that. And again, this is not going to protect you against sophisticated attackers, but most thieves aren't going to even think to look for something like that. So that might be an option for you. For added security, ultimately, and you could read about this by geeking out with the documentation, if you're going to roll this into production, theoretically, not theoretically, periodically, you need to rotate your keys on the Tang server. So that's just a note that you need to do. And now, it's time for our demo. All right. This is the cool part. So, like I said, we've got... up here, we've got our Tang server, and over here, we have our big iron. This is representing our big iron quote server. That's part of our Kubernetes cluster or something like that. And this is running the Clevis piece that we've been talking about. And what I'm going to do is I'm going to disconnect our video, because that's enough slide for right now. And, I mean, we're doing this right. I mean, I could have used a video capture device, but this is way cooler. All right. And now next up, we will plug in the power for our big iron server. Drum roll. Oh boy. Now, this is a Linux conference, so let's geek out on this a little bit here. So these two systems are running Debian just because it was relatively easy, but setting up encryption using the Debian installer. The Debian installer does make this pretty easy, but doing it on a Raspberry Pi is another matter entirely. Normally, you install Linux on a Raspberry Pi, you stick it on an SD card, and it comes pre-configured, and it's not exactly set up with encryption. So in order to use the Debian installer, you can easily put the Debian installer on an SD card. And then in this case, I actually installed it on the USB stick that is sticking in over here. It's one of these little stubby USB sticks. And that's great, except to actually make it so that you can boot off of that, you have to turn on UEFI support. And on the Raspberry Pi 4, that was fun. So I've got a link as to how to do that at the end if anybody's interested in that sort of thing. But it was less than ideal. It worked eventually. So anyway, here's our big iron server. And I actually had the network cables connected because, we did this wrong. But that's okay. It actually worked. Now let's watch it not work. So we've got a simple Cat5 cable between the two. I'm going to disconnect the Cat5 cable, and then don't try this at home, kids. We're going to just power cycle the thing by unplugging it. Yay, journaling file systems. All right. So now, as it boots up, we'll again see Raspberry Pi nonsense. There we go. And here we see grub. And there we go. So we've got initramfs doing its thing, and it's just kind of hanging out there saying, I don't know what to do. And also, full disclosure, I've cheated with this. I'm using IP addresses. So by default, Debian does not have the stuff to do DNS resolution within initramfs. Red Hat does. This stuff just tends to work better on Red Hat-based distributions. It's easier. I've gotten it working with Debian before. Basically, you have to add glibc and stuff related to DNS resolution, and then make your init rimfs flippin' huge, and then that'll work. But for this demo, I just cheated and used IP addresses. Anyway, so yeah, it's doing its thing, and I could enter the decryption password, but that's boring. So instead, let's plug in the network cable. And I think it got an IP address. It's kind of fuzzy. Look at that. It's working. Cool, huh? Voilet, as they say in France. All right. Well, no. The demo gets more interesting. Hold your applause. Just wait. Okay. So now we're going to log in. A Lux dump? Maybe. Yeah. No.
Well, you said 1 through 8, and I'm looking for key 0.
Yeah, okay, sure. So anyway, I've got two scripts here. We've got tang it and decrypt it. So I'm going to show you what's inside of these here. So inside of tang it, can people see that in the back? It's not huge. It's okay. Yeah. Anyway, so what we've got here, I'll kind of walk you through for those that can't see all in the back. What we've got here is just a simple bash script, and it's saying clevis encrypt tang. No, it's actually encrypt. So this is the tang piece. So you'll see. So it's clevis encrypt tang, and then we've got some JSON nonsense, and in there basically we're saying URL, and we're saying HTTP, and our IP address that's at the other end of this. So this is what's useful. We're actually going to encrypt a message with tang, with using clevis and talking to the tang server. So hold on a second. I need a message. Oh, come on. Hello, world is too boring. Come on. What was that? All right. A little less religious. Yeah? Nothing? Texas Linux Fest. Okay, there we go. All right, so for those in the back who can't see, that's Echo Texas Linux Fest with an exclamation point, and we're piping it to that tang it back batch script. Now, I think we've got quotes on both end. Okay, and it's asking us, do we want to, Okay, it's back. Let's be more gentle next time. It's asking us on the bottom, do you want to trust this key? And, you know, our options are yes, no, and whatnot. You know, this is similar to establishing trust with SSH, and you could already seed this, you know, if you're being really responsible in a proper production rollout, but we're just, you know, messing around here. So we say yes, and it spits out a JWE binary blob, base 64 encoded. So actually what we're going to do this time is we're going to take that and we're going to redirect that into a file. TXLF.jwe. All right, so now we're redirecting the output to a file. Again, we say yes, and now our file. Our file contains that. Great. Okay. Now, round two. With that other script we've got there. Decrypt it. It is much, much, much simpler. All it says is clevis space decrypt. So what we're going to do is we're going to take the output from that file that we've got there, the JWE file, and we're going to pipe that into clevis decrypt. We're not even going to bother with the batch file. And like magic, there it is. Texas Linux Fest. So what we just did there was our Big Iron server just communicated with the stupid lightweight Tang server, and using the Michaela Rayla handshake, just reconstructed our message. So look at that. You can not only use this for your key at boot up, you can also use it for this. Does anyone have any questions about this?
So if you were to disconnect,
Hold on a second.
so if you were to disconnect the network cable between them and then run that again, it would fail?
If I disconnect the network cable, it won't work because it needs to access the Tang server. If I reconnect it, it'll work then. Another question?
So I'm a web developer, at least in a past life. I've used JWT encryption for authentication, and I know the three-letter acronym JWE to be a key lookup service. When we're talking about JWE here, is Tang acting as a key lookup server?
Or is it derived?
Is it deriving the key? I'm not sure exactly, but it's certainly reconstructing the key. And I would encourage you to go check out the GitHub pages that describe all of this in much more detail. I'm hardly an expert on JWE, but yeah. Any other questions? Lux, what? Yeah, no. All right, so back to the presentation. And the snarky questions are appreciated. I mean, if you do see the master key, you're going to see the master key for my demo rig. Ooh. Oh, I misspoke. I think you're right. Yeah. All right. So, live demo. Yeah, okay. So we saw the live demo, and that's if the demo gods weren't happy with us, but clearly everything was fantastic. Yeah, so what the solution protects you from? It protects you from common thieves, but what about really sophisticated folks with skills? Yeah, I mean, ultimately, they've got you and your data. Actually, you know what? I want to bounce back to something we were mentioning earlier. I was talking about that thing with the Pico Pi and lifting the decryption key off of the legs. In practice, that's much harder these days because the TPM module is actually usually encased in another chip. It's not its own discrete chip, so you can't really do that, but you can still do the laser nonsense. So ultimately, you should be doing some sort of defense in-depth strategy. One of the options is that Clevis supports Shamir secret sharing. So you could theoretically have both TPM and Tang as a requirement for boot. So you could go for both of those. We want to make things more secure. You could also require a quorum of Tang servers. So you could have a requirement you could have 3 Tang servers and have a requirement for at least 2 of them. You could have 5 Tang servers and have a requirement for at least 3 of them. So you've got options if that's what you want. I mean, that's certainly that sort of thing. But, with great power comes great responsibility. And ultimately, this comes down to a business decision. So un-TPing TPM a little bit. I was mentioning before about the whole thing with the legs and how it's a little harder to rip it off the chip these days. TPM 1.2 was a total disaster. It was horrible garbage. TPM 2, it's much better defined. It's much more consistent between vendors. It's much less of a poop show, as the kids say. But TPM, it is what it is. It really supports bootlocker well. It sort of supports Linux. I mean, you can kind of use it. I haven't really played with it too much. But at the end of the day, it is a kind of tiny computer. It's got an API. It probably has vulnerabilities. The TPM itself is slow. Not that you really care, because booting, it tends to be slow in general. But It can also do other things. I mean, for instance, you can actually use the TPM to store open SSL keys. So that might be interesting if you're running a bunch of web servers and stuff. You could theoretically validate that stuff hasn't been tampered with when you're booting up. You could conditionally decrypt volumes based on both of those things. It does stuff. So anyway, TPM, kind of a mixed bag. It's not open. Boo. But, you could use it in production. It is a thing. But with more complexity, that means that more potential for DOSing yourself. Not good. So how to avoid crowd-striking yourself? I'm going to go over this really quick. So, yes, CrowdStrike is also what happened with CrowdStrike. It's also an argument for Linux desktops. Let's hear it for Linux desktops. Yeah, woohoo. Yeah, okay. But, if you were rolling this out in production, you might have some sort of product like CrowdStrike even running on your Linux desktops. But, that was just a whole mess with how Windows boots and whatnot. And it was a huge disaster. So let's skip over CrowdStrike here. We're running low on time. So network-based decryption, what does it mean? It means making yourself dependent on your network. Could you still partially function without an internet connection? So some questions you probably want to ask yourself when rolling this sort of thing out or thinking about rolling this sort of thing out. How valuable is the data that I'm looking to store? What's the cost if it's stolen? And what's the cost if it's not only stolen but distributed? Given my threat model, how do I hide my, quote, keys? Remember, in this case, the keys would be on your Tang server. What is my total cost of disk encryption solution rollout? I know as nerds, we always like to think about how cool everything is to roll it out, but there are real costs to this sort of stuff, and your CPA and CFO will let you know about them. So, what are the ongoing maintenance costs? Oh, I can roll out this really cool thing, but how much is it actually going to cost to maintain? So ultimately, we should be securing our Linux systems with purpose. The cost to implement and maintain our, quote, fix should be less than the cost of the theft times the probability of that theft or other badness. Takeaways. Tang and Clevis are open source. You need both the Tang server and the Clevis server to decrypt things, the Clevis client to decrypt things. If you only have one, you've got bupkis. You can add extra decryption requirements, pins to Clevis, like TPM2, or you could require a quorum of Tang servers. Make sure your encryption solution actually makes business sense. So, at the end of all of this, your CEO hears about your solution to roll all of this stuff out and is just tickled pink. Everything's wonderful. Thank you very much, folks. Do we have time for questions? Question. Okay, yes.
Thanks. First, I just want to say, wonderful presentation. I have been interested in this space and practicing for quite some time, but I'm always very happy when coming and hearing a presenter who clearly knows what they're talking about and can present in a directly applicable manner. Thank you for that. The question is, in my experience with Tang and Clevis, which is dated at this point, it was only Lux based. Do you know if it's possible to use Clevis and Tang, this type of solution, with something like ButterFS or ZFS, where they also have full disk encryption and require keys?
I'm not sure if there are any active implementations to do that, but as you just saw as I demoed how we decrypted a message, theoretically you could implement it yourself. I guess you could. I'm not aware of anyone who's done it, but yeah, go check online. Any other questions? You've been a great audience. Thank you very much. Have a good afternoon. See you at the happy hour.